Hi, I'm Nick Wills. I'm the electrical engineer here at Holden Racing Team. Been with the team for 9 years now. Before that I was with FPR, and before that I was an avionics engineer with Ansett. Here we are in the Walkinshaw engine shop. I build all the looms for these engines, which go through the firewall to the ECU, and what we get from the engine is the sensor inputs from temperature, pressure sensors, throttle position sensors. The ECU controls the fuel delivery via the injectors, and also the spark to the coils, which in turn supply spark to our NGK spark plugs. Keeps our engines spinning away, spinning our alternator, which keeps the power to the car. The engine looms are built down in their workshop. It takes about 8 hours to build. And I'll also supply oil temp sensor, engine temp sensor, a sync sensor, got a crank sensor. Then we have our race spark plugs, which are changed every service, probably every 3,000 k's, just to ensure reliability, but they'd obviously last a lot longer. We use NGK spark plugs because of their reliability and good quality, and also longevity. For instance, Pukekohe, a lap, 8 spark plugs have sparked over 26,000 times. My day consists of building steering wheels, looms, switch panels, also stock to keep stock of the spares I might use at the racetrack, wire, heat shrink, connectors, all that sort of thing. Any issues that guys find in the cars when they're stripping them down, and I'll attend to that and fix that. Here I've got the chassis loom that we're putting into Garth's new car. From start to finish in designing a loom, you need to work out what's going in the car, where you're going to place it in the car, and then basically measure out how you're going to route the loom inside the car. I use TEF cell wiring, which is a bit different than your normal automotive wiring, whereas the insulation is a lot thinner, it's a lot more heat resistive and a lot lighter. Another part of my role here is programming all the radios. I have to go through all these radios before each round. Also look after the driver's helmets, the radio kits in those. That can be challenging sometimes, especially with, they've got water, drink bottles, that water goes in there. Got to have the microphone set in the right place, especially with digital radios. If you're out of range, you'll completely drop off, whereas with your analogue system, you just get crackles and you'll be able to hear them still. So there's a few things we've had to learn along the way. This is a steering wheel out of GT's car. He runs the display and the shift light module. This display gives him warnings of any issues with the car, alarms. It'll give him his gear position, his RPM. This is the pit limiter button, which basically restricts the car from going above 40 kilometres an hour. And we've got our acknowledge button. If we're talking to the driver and he hasn't got time to talk back, he'll just push that to say he's acknowledged the question that he was asked. CPS lights, an alarm button, wiper control, page, you can change the page, drink pump, and then you've got your line locker. And this line locker is used at the start of the race, where they can hold the brakes down, push that button, it'll keep the brakes on. They can take their foot off the brake and ride the clutch and accelerator for the start of the race. Okay, at the track, my role is looking after all the electrical side of the car. If there's any problems with sensors and so forth, I'll replace them, and also all the radio communication equipment that we run. So every morning I'll do a radio check to make sure that our side of the radio comms is working. 1, 2, 3, 4. 1, 2, 3, 4. When it's race time, my role is to look after the fuelling of the car, which means I've got to suit up in the fire suit, make sure the fuel figures are right from when we fill up with fuel, and make sure that we're going to give the correct figures to our data engineers and they can work out the strategy correctly.